Hello everyone, welcome back to my channel. This is Purna. In today's video, we are going to talk about the factory design pattern. Here is the agenda for the sessions today. What is factory design pattern? We will discuss about the benefits of using factory design pattern. In-depth look into the implementation of factory design pattern and live code example of factory classes. So what is factory design pattern? The factory pattern, sometimes referred as factory method pattern, it falls under the category of creational design pattern. As the factory name suggests, it means to construct or create something. Within software architecture, the factory pattern served the purpose of centralize the object creation process. Here are some benefits of using factory design pattern. The factory method encapsulates the object creation logic in a separate class, which makes it easier to maintain and test the code. The factory methods decouple client code from the concrete class. It uses client interact with the factory interface, not the concrete classes. This reduces the dependencies and makes it easier to change the substitute object types without affecting the client code. The factory method pattern can be used to create families of objects that share common properties and behavior. This can help to promote code reuse and the improve overall maintainability of the code. The factory method pattern can make code more testable by isolating the object creation code from the client code. It supports for the future extension, and this pattern makes it easy to add new type of object without having to change the client code. This can be useful for applications that needs to be able to evolve over time. The factory pattern also has some disadvantages like code complexity, abstractions overhead, increased number of classes, etc. How to implement factory design pattern? A factory pattern says that just define an interface or abstract class for creating an object, but let the subclass decide which class to instantiate. In other words, subclasses are responsible to create the instance of the class. In this example here, the vehicle factory is responsible to create the object of vehicle based on the type supplied from the client, and the possible parameter types could be bike or car. Another example here, the connection factory is responsible to create the object of database connection based on the type supplied by the client, and the possible parameter types could be here the Oracle and SQL Server. Based on that, the client will get the connection object of particular connections type. In future, if we need another database connection, for example MySQL database, then we just need to create a concrete class MySQL connections like SQL Server connection here by implementing iConnection interface. And from the client, just need to pass MySQL type to the connection factory, and we will get the object of MySQL connection from the factory. This is how the factory pattern supports the future extensions without changing anything in the client. It's time to write some code for factory design pattern, and let's understand what is the problem this design pattern solving. Let's go to the Visual Studio Code. Before we implement the factory design pattern, let's understand this bad code example, and later we will convert this with the factory setup. In this code example, here we have two concrete classes, bikes and car. We are dynamically creating instances of either a car or bike object based on the type variable, and it invokes the drive methods on the respective object. Here the client class is performing an additional responsibility, and it's a violation of solid principle. We can delegate this object creation responsibility to a separate class. By using factory method here, we can create a new vehicle class without altering the client class code, and this allows for a more flexible and extensible code base. This code base is tightly coupled. We can decouple the client class from concrete implementation of the vehicles, car or bike, using a factory method. Instead of relying on the specific classes, The client depends on the abstract vehicle class or interface, and this promotes the loose coupling and reduce the dependencies, making the system more modular and maintainable. Let's create a factory folder. Inside the factory folder, we need to create a new interface called iVehicle. That declares an abstract method called drive. This interface will serve the blueprint for vehicle classes. Then we need to create two classes, car and bike. This class will implement the iVehicle interface. Let's implement the functions. Let's write something in the console. Puts a prefix factorypattern driving the car. Let's copy this into bike classes as well. Instead of car, we will write bike. So our iVehicle interface and the corresponding concrete classes bike and car, which is implementing iVehicle interface, and it has a method drive that we need to override in these two classes. The next step is to create a vehicle factory. Let's create a class. And this class will have a static method create vehicle, which will return the subclass of iVehicle. And based on the type parameters, it will return the object of respective subclasses. So our factory class is ready. Then let's go to the client. Now we have to call the create vehicle method from the vehicle factory class that will return an object of the subclasses, so that we need to hold it in through the object of interface. Vehicle factory dot create vehicle, then we have to pass the type. So then we will get the object of vehicle factory. Then we can access its function now. Similarly, we can also access the object of bike by just passing the type as bike. Okay, so our consuming code is ready. Let's run this application. Here we can see the factory pattern driving the car, here driving the bike. So this is how we can pass the type of the class and retrieve the respective subclasses object, and we can use. So in this client, we are not creating object. Basically, we are retrieving the object from our vehicle factory class by passing the types. There is still scope to improvise this code. So instead of passing this string, we will pass the enum. So let's create one more enum here. So let's create two types, bike and car. We will use this in our factory as the input. And also we need to change the client. So that we can minimize the error of typo. Let's rerun this. We must see the similar result as earlier. So this is how we can convert this bad code example where we were creating the object in the client itself. And this is a clear violation of single responsibility principle of solid principle. So that could be separated or delegated to the factory class. And by passing a type, we can retrieve the desired object of the subclasses. And this is also decoupled. Let's go back to the PPT. In the conclusion, the factory design pattern is a creational pattern that enhances the software flexibility, decouples the code, and centralizes the object creation. It simplifies adding new object types, promotes testing, and improves code organization. Its ability to adopt and extend object creation logics makes it a valuable tool in software design. Thank you. See you in next sessions with another design pattern. Thank you for watching this video. Don't forget to like, comment, and share. Please subscribe my channel.